with Mr. Anderson?
Man, didn't you hear he has pancreatic cancer? He's probably gonna die soon.
What do you mean? I just saw him beating Luke on the tennis court like 3 months ago.
Remember how he couldn't kick his stomach bug and he was feeling nauseated all the time?
Yeah, and we were making fun of him because his pants kept falling out because he lost so much weight.
Well, apparently that was the pancreatic cancer. My mom told me pancreatic cancer is bad because the symptoms don't look bad until the cancer is spread. Mr. Anderson turned yellow, like his skin and even his eyes. That's how they knew something was wrong. My mom mentioned that it was weird that he didn't have any of the qualifiers which put him at risk for cancer. Like he's a guy, and it's usually more common in women. He doesn't smoke, he's not overweight, he didn't have diabetes or any history of a problem with his pancreas.
Why doesn't he just take it out with like chemotherapy?
Doesn't work. One here will freak me out. Without treatment, the median time of survival from the time of diagnosis is 3.5 months. With treatment, only 8. You have to surgically remove the whole thing and hope for a cure.
Why doesn't he just do that?
Less than 20% of people can. Because the symptoms are so mundane, you only know you have it when it's spread all over. He only has a 7% chance of being alive.
What Cole and Justin don't know is that there is hope. Pancreatic cancer is unique because over 95% of these cancer cells have the exact same cellular mutation, a defect in the KRAS gene, which codes for the KRAS protein, the major regulator in the RAS cell signaling pathway.
KRAS is activated by guanosine triphosphate, seen in green on the board behind me. When active, it transmits signals to the inside of the cell, telling it to grow and reproduce. In a healthy cell, signals come in from the outside and bind to receptors on the cell surface, which tell the KRAS protein to stop, slow down, and even to die. The KRAS then dephosphorylates the GTP, turning it into GDP, deactivating itself. However, once mutated, the activated KRAS cell mutes incoming regulatory signals and goes rogue, continuing unabated growth and proliferation without regard for what it might be invading or even if the cell is functioning improperly.
Additionally, pancreatic cancer typically involves a second mutation in one of two tumor suppressive genes, P53 or P16. P53 is inactive in approximately 70% of all cases. There are some familial genes, like the BRCA2, but the ultimate end defect still lies within the KRAS and a deletion in one of these tumor suppressive genes. As of right now, hope for Mr. Anderson lies within the researchers who are utilizing their knowledge of cell signaling pathways that have gone awry with pancreatic cancer. Targeting treatments aim at controlling the KRAS protein in one way or another. The most attractive approach is to synthesize molecules which bind directly to the KRAS protein and make it ineffective. Additional possibilities are to disrupt the KRAS's location on the membrane, essentially knocking it off, rendering it useless, to attack the growth signals produced by KRAS, and to train the patient's own immune system to recognize those cells which have the KRAS mutation, and to treat them as if they are foreign body and kill them. Finally, additional research does hope to return the tumor suppressor genes back on.